So, let's give a warm applause for Matias, and he will tell us more about it.
Okay, hey everybody, my name is Matias, I work on the Angular core team. I'm in town this week for the We Are Developers conference, and Igor from my team asked if I could get in touch with Martin and speak at the meetup, so this worked out very well. And I put together a presentation that talks about how the styling in IB and what that took to redevelop it, and how that's changed. Now, the API outside of this hasn't changed. But just like Martina talked about, the internals of everything have changed. And I was very happy that she presented before me because she gave a nice introduction to all the stuff I'll talk about now. So, that's a nice photo of me. Well, we had NG Vikings a year ago in Finland, where I was born in Finland. Because it was a Viking themed conference, so I thought of a Viking look. It worked out well. But I've been working with Angular for 7 years. And I've lived in Finland, Canada, now I live in the United States, in San Francisco, and I work on the Google Angular core team in San Francisco. And that's my Twitter handle. So, what I will be talking about today, I was going to double check, yeah, perfect. What I'm talking about today are these things in Angular. Styling refers to class and style bindings. And there's 6 ways to do these. You can just have regular bindings, with just static values. You can have single properties, and you can have multiple properties. So what's the use of styling bindings? I'm sure everybody knows in this audience why they're important. Obviously, if you want to add color, and you want to style the website and have interactivity, you need to have these things. For developers using Angular, I'm pretty sure no one really thinks about how they work behind the scenes, because it's just an API. You're using it and it's doing its job. But there's a lot that goes on under the hood. And this is the analogy I want to compare it to. So everybody knows what this is? Yeah. Which game console is it?
Nintendo.
Super Nintendo.
What's the Japanese version called?
Super Famicom.
Yes.
What?
Super Famicom.
Okay.
For family computer.
Yes.
Okay. So it's a controller, you push buttons and you use it. You're not thinking about what's happening behind it, right? The public API are all the buttons. The internals are something else. No one thinks about the controller and how it's getting all the inputs and sending all the signals to the game console. But it looks like this under the hood. I don't know what happened here. I think a dog bit it off or something. But I was looking this morning for photos. Anyways, this is what it looks. Oh, yeah. It looks like. No, it doesn't look damaged. It's just that. Oh, something happened here. Anyways, these are all the buttons, and this is all the circuitry underneath. So if you think about directives and all that stuff in Angular, they have the code underneath that accepts the inputs. And the style binding stuff, because it got refactored in the framework, we basically had to tear it all away, figure out how to make it work optimally, and have it do exactly what it's intended to do. Another example of this that makes more sense is the video tag in HTML. Now, when you use video, it's not a div, it's just not a container. It actually puts the video into the space, and it adds the controls, and it sets the autoplay. This is basically a web component, but it was around before web components were introduced. But really what's happening here is it's accepting the inputs of control and poster, and the content inside as data for it to do its thing. This is what it looks like when you recreate the component in Angular. You have inputs and content children. So what I'm trying to drive here is that you have a public API and then you have the internals that deal with the information from the public API. Basically, the first thing you think of when you have programming. Functions and input data. So with styling, let's use ng class and ng style. These happen to be directives right now in Angular. They do the job. Now, when you use ng style and ng class, you're probably not thinking, oh, it's a directive. You don't care what's happening. All that's happening is the styling data is coming inside, and it's evaluating the styles. So with the styling bindings that we have in Angular today, these are all the different ways that you can add styling to your application. Now the first three are the most important ones. You can also just set the attribute directly. So if you want to set style right now, you can't do that because there is no style binding. That's why we have ngStyle. However, you can do attr.style if you want to set the string to the element. We can also use the render as well, but I'm not going to go too much into that because Angular doesn't encourage it, because you're kind of sidestepping all the algorithms that we built to make this run well. The stuff I'm going to be talking about in Ivy today is all of this stuff, how it was basically redone from the beginning, and what the three different things that are used or were developed for this new refactor. So we have the compiler. This is a lot of the stuff that Martina talked about with Ivy and the AOT code and the instructions that are produced. And there's a diffing algorithm that takes those instructions and figures out what to do. And there's a ton of improvements with this new algorithm. So if you think about the template code, just as we saw in the previous presentation, each of the elements in the template code, the attributes and the bindings, are all generated to be instructions. Basically, the compiler goes through everything, and it produces instruction code, and then we have another compiler that takes that information and produces JavaScript code, and then we save it to a file. This is the idea of AOT. And the style instructions and the styling bindings are also part of the same instructions. So what do you think happens here? How many instructions do you think there are?
5.
5?
A 6. No, 7.
It's kind of hard to say, but like, there's a handful of instructions, right? Depends how the instructions are written. But this is what it looks like. If you remember I'm very happy you went before me. Perfect. It worked out very well. Because that function that she had highlighted this is an example of it for that div element. Now there's some things I kind of changed around in the code to make it a little bit easier to read. But basically what's happening here is that first we create something and then we update something. We are creating a div, and we're giving it an ID of 0, and we're giving it a class of modal blocks. So here you can see modal blocks is a static class. That's never going to change. So we're giving it that, and then we're setting the text, and that also happens to be static because there's no bindings inside, so we create it right away. And then in the update phase, these are when all the bindings are processed and applied. The only thing that doesn't really make sense with this example is the select to 0, but that's basically saying we are applying all the attributes for the 0th element, which happens to be the div. So when this runs, it's going to update the disabled class, the width, and the height. And the context values right here are the component's data. So that happens every single time this component is dirty. So if something has changed, it's going to run this code to figure it out. So when you're playing with the controller, and you're pushing the buttons, these are all the signals that are coming in from the buttons.
So the answer was 5.
Yeah.
Why no comment?
But it's kind of hard to guess because it's like maybe it's the select instruction. But yes, you're right. There are 5. Okay. Here we have all the instructions that could be created from these. Now, something in here is a little bit off, right? Look in the middle at style and class. We have style map and class map. So that means that we are changing ngStyle to be called style, ngClass to be called class. They're not going to be part of the common module anymore, they're just going to be included into core. But they will be tree shapeable. So if you don't use them, then they won't be included into the bundle. But this should make it a little bit easier to read a template because everything is just style.property, style, and then the static styles. So these are the different kinds of instructions that could come in. And the algorithm has to figure out how to apply all these very efficiently to the elements. So, Ivy styling is the algorithm that applies all of these instructions to the elements. And there's a lot of requirements for building this thing. If you have styling bindings on a component or a directive in the host binding area, and if you have it on the template, they're all targeting the same elements, you need to make sure that it's going to be applied with the correct set of styles. So the overriding works in the correct way. You have to make sure that it renders only once. So you don't apply styles unnecessarily every time there's a change detection that occurs. Finally, you want to make it so it's fast, and then if you don't include certain instructions, it won't be included into the bundle. And of course, smaller size and faster. Now, a big part of this is getting the JavaScript code, to be as efficient as possible. This is what I have to deal with every day at work. It's kind of like having a diet and not being able to eat any candy or food. Because there's all this stuff in JavaScript that I would like to use, but I'm not allowed to. Basically, it's just arrays and numbers. So I don't know what
That's
that
like C programming.
Yeah. Mishko, the guy who made Angular, used to build compilers as well, so he took all that knowledge and threw it into this. This is kind of like eating only meat and like a specific lettuce, like leaf, all day. Okay, so what does this look like? Well, the idea here is that we have fixed code, and that's code that's generated. There's no dynamic pieces in here, so AOT code is generated from your component, but everything else should be static. And then dynamic code, anything where something could expand or have more data that comes in, is inside of arrays. So the first one is faster than the second one because the name property is known during compilation of JavaScript. So JavaScript can look at it and be like, oh, okay, we have a name value. I can set up the code to update the name very effectively. The second one is dynamic, so it's slower. And this is actually 100 times slower than the first one. Now, you don't notice this because JavaScript is obviously can do millions of these operations a second. But when you're building a framework that could use hundreds of thousands of different websites and different combinations, you want to make things incredibly fast. So whenever we can get away with having static type objects, we will. And TypeScript is very good with this because TypeScript can require us to have an object of a certain size and shape. Yes?
Isn't this a change of type from null to string? Why it's slow?
I think it's about monomorphism versus polymorphism in this example.
So, yes, you're right, it is changing type. Now, I could have put an empty string in here. What I was trying to get at was the fact that the name already exists in the object.
Okay.
So it's, yes?
Okay. Another question. Inside the team, you're using like special linting rules that you're always adjusting to this pattern, or?
TypeScript.
Yeah.
TypeScript does it for us. Because we have every single object has a certain type, and as soon as you try to add a new property, it's like, I don't know how to deal with this.
It is hidden classes, isn't it?
Exactly.
Yeah.
That's the point. Did I answer your question, please?
Yes, because I understand. Well, if I understand correctly, the compiled code should be optimized for V8 directly to leverage the essential engine underneath it.
That's exactly.
Good that you have to deal with it.
Yes.
Thank you.
Good and not so good.
Yeah. Thanks that we don't have to do.
Yeah. This is all over I do. One of the reasons why it's taking a lot of work to get this going is because we've been very, very careful with this. Now, what about this? What's the difference here? Well, we're still dealing with it somewhat statically, but we're using an array. And this is only 10 times slower. So meaning the first one is 10 times faster than the second one. But in these cases, even if you use a map or a set, or just a string map, they're all the same. They're all just as slow. So even the array one is going to be 10 times faster than the map-based one. So the bottom line is that we try to get away with things that are very static. Now what about things that are kind of constant, to say like enums and constants, and if we use a lot of arrays, we still have to have constants to know exactly where to go into the arrays. Well, let's talk about bundle size for a second. this is a class. Let's say that we're updating styling with this class that we have. We have two methods on the class, and we have a private value. If we update the values, we set the flag to dirty, and then if it is dirty, we can return it. What does this look like when it gets compiled into ES5 and then minified? This is what it looks like. It doesn't really look much smaller, does it? Now, this is kind of the problem with ES5 and not ES6, because ES6 could, you could keep it just as small and maybe do a little bit of minification. But really, the problem here is that there's only so much that you can minify. And ES5 has all these things like function and prototype that are required to be in the source code, which adds a lot more weight to the bundle size. So we don't do this at all in IB. What we do instead is we use enums in TypeScript and interfaces. What the enums allow us to do is that we can access values directly in the array because we know where they are. The nice thing about TypeScript is you can have a typed array that says at this index location it's this value, at this one it's this value. And then what you do is you have a bunch of functions that interact with that array directly. So yes, it's very, very C-like. It's almost like writing, I don't know, a compiler to compile C. It's very, it's very, very low level.
But at least you can write it in TypeScript and not in C.
Yes.
It feels like code golfing, making it smaller.
Yeah, code golfing. Yeah, exactly. The nice thing about this is that it looks like this when it gets compiled.
Oh.
That's why you guys are saving 30%. We still have a function. So even if you have ES6, you might be able to get rid of the function as well. Of course, when ES6 comes around fully, we'll save even more space, and we don't have to have as much of this complexity when it comes to saving code size. Okay, so we have an idea about ID, and we have an idea about the optimizations. What about this styling algorithm that we have? Well, what's happening here is that it's getting all the instruction data, and then it's rendering what it has to render accordingly. One thing to kind of drive clearly into, into the knowledge base of how we are doing stuff with ID is this idea of having a template versus an element. Now, template, it could be used for so many different things. What it basically means here is that you have some kind of template that defines something, in this case a component, and an element is an instance of a component. So it's like a class and an instance. If you order a laptop from Apple, you have the idea of a laptop, and then you get an instance of a laptop. And then it's not like you get one specific manual for your laptop, and you can only read that one manual. You can read the Apple manual. So that's the relationship I'm trying to drive here. So inside of ID, and deep in the code, we have something called a tNode. And the tNode contains all the definition information for an element. And then we have something called an LView, which is the RAM for the component. And the RAM stores all the information about all the bindings, and it stores all the values from the component. So, like I said, the tNode is the definition, and the LView contains all of the instances of the items from the definition. So if we have this is the template. Just the HTML code is the template. Nothing has been instantiated yet. And this template code has all the bindings that we have in here and the text as well. But actually, no, the text is more about an instance. So in this case, all we have is just the binding data and the class. All of that stuff is static. There's no actual data in here because we're using the tNode to build the bindings later on. And every time you make an instance of that particular HTML element, the LView gets populated with the actual values that you have. So it's basically the RAM of the component. So styling uses this template and LView relationship to store its values. Every time one of those instructions runs, it's storing its value inside of the LView at the right spot. And then at the end, we have another object where we know exactly what values to update on the screen. So back to this example, we have three bindings and we have one static value called modal box. this is what the data looks like in our tNode. Here we have the instances of the bindings, width and height, and then we have the classes disabled and monoblocks. We also have some other values in here. The bit mask and the total. The total is telling us that height only has one value, because I haven't filled in the values for bit mask and total, we'll see that. But the height value is stored at index 31 in the RAM. And then the default value for the height is going to be null, because we didn't have a static value. But modal blocks, because the modal blocks is a static value, class modal blocks, we can see that it's true. So the styling compiler sets up the instructions, and when the instructions run, they build up these data structures. Yes?
How does it know afterwards which index of the array is which information? Because the last line bit mask with modal box is one element less, or one element less than the other ones.
So every time, let's see if I can find these instructions.
Sorry if I...
No, that's fine. Okay, every time these instructions run, they always run in the same order in the IB compiler. So there's a counter that increments. So the counter is basically this address that you have the RAM that's going through every single slot in the RAM. So we gain access to that increment, and then we store it into the template. Okay. Because every time it runs, it's always going to be the same value.
What does it? Can you go back to the
Gotta go backwards.
What does T and the L stand for in tNode and LU?
So T is template, and L I believe was instance or logical, like the logical. Like we just use this prefix to help identify the things that are static and the things that are runtime.
Because L is not the instance.
Well, logical, it's like. We've been working on this for a few years. Maybe it was another idea when we started. That's where it came from. Okay, so we have this. This is really important because this array, which is the sort of manifest of all the styles for this element, it goes over them to apply them. But before we talk about that, let's talk about bit masks. Probably not the most popular topic. But these are
Now we're really at sea.
These are really cool because if you have enough data up front, you can use them for any kind of cache and validation or whatnot. So basically what's happening here is that because that counter is incrementing, we can have a unique ID for every single binding. And then what we do is we generate a bit mask for every single binding here. So because the width is the first value, we say that its guard mask, the bit mask for it's going to be 1, and the bit mask for height is going to be 2, which is the next bit over. And then the same thing for the classes. So right now, just think about it, it's a big number, and 1 bit in each of the values for the number corresponds to the style. So then, when the change detection runs, it's able to figure out exactly what style it's on, figures out what bit it needs to set, and it updates another value called an update mask. So it says, oh, okay, the width and the height changed, so it's going to update both the first binding and the second binding. And when the class updates, it's only going to update the first one. So we have these two variables that just live in the memory of the application. And then when we want to apply the styles, we go through the array and we say, it has this value changed, update, it has this value changed, update. And the biggest trick here is with the if statement, all it's doing is it's like, have any of the bindings for this particular property changed, go ahead and update it.
Is this general for the change detection, or is this just for style bindings?
This is just for style bindings and internationalization.
Ah.
Yeah.
But what if we have a many properties that so bit mask is not enough?
I went over 32 in JavaScript and it worked. So I think it goes up to 64. 64 different styles for one element, which is probably not going to happen.
Okay. So now I know how to pattern.
What actually would happen if there were too many? Would it then just be disabled, or will it break?
No, that means that once it goes past 64, every single binding turns on, so it becomes inefficient.
Yeah, but it will not break.
It will not break, so it's much easier for you to refactor your application. And the multiple style bindings with the map, that is just one. It doesn't, you only have one binding.
It's the same property.
Yeah. The same thing happens with classes. The only difference here is that it's calling set class instead of set style. So here's an example where we have a bunch of bindings that all write to the same property. They're all writing to width in many different ways. What's happening here then is we actually have three bindings. We have one directive that sets width, we have another one that sets width, and then we have another one here. So these bindings right here are all the binding locations for the width property in the view. So then what happens is, when the change detection happens, if any of these bits have been flipped, if any of these are true, any of these have changed, it says, oh, okay, the width needs to be updated on the elements. And then it says, which one is it? It goes through 34, it goes through 35, it goes through 30, 33, 34, 35. And the first one that gives it a value that's true, it writes it to the page. So the prioritization is saying, this is the most important one, and then this one, and if that fails, we write the default value of 200 to the elements. The nice thing about this is that the entire algorithm is O of n, no matter what. You'll never have nested for loops. Even if you have the multiple style bindings with the map, it still is O of 1 every time. Oh, sorry, O of n, not O of 1. Okay, so what does this do for Angular in the long run? How does it make things better for us? Well, the prioritization, like I mentioned, there's a distinct prioritization. Right now, I think in the view engine, if you update one style binding, and then you update ng style, and you update the other style binding, it falls out of sync. With this one, it's always guaranteed that the template wins, and then the directives, and then finally the component win. So in this case, if the style.with the w updates, if that value exists, it's not falsy, then that gets set. Otherwise, it tries dir that sets width. Otherwise, it says another dir that sets width, and finally, it tries the map.
And the last one would be if there would be a static style
Yes.
binding.
In the priority is the order of appearance in template.
That's what we're trying to change right now. Right now, it's the order that they're registered in ng modules. But because this is a brand new feature, we're still trying to get this to work. There's also another one with the component, because the component called with component can also have its own host bindings.
This is last or first?
The component is the last one unless there's it will be the last one. If there's a static style, that's also going to be after the component. So think about it, the easiest values to change are the ones in the template. Because you have if you're using somebody else's plugin, and you don't like the way that they set the color or the width, you can make your own styling binding on top of it, and it will update it. And it'll always know that that's going to be applied. Yes?
But will it then take the highest priority all the time, or when chronologically another directive that is on low priority changes, will it take that value over the high prioritized but later, earlier emission?
No, because what happens is the old value is still there in the memory.
Yeah.
So when the new value updates, it says, oh, the width has changed, and it gets the old value. Because the old value has a higher priority. So
I could, if I'm prioritized lower with my directive, I can do whatever I want. I won't be able to override the higher prioritized.
You just generate useless change detection.
Yes.
Yeah. Good to know.
Well, I would imagine that 90% of the time, you don't want that to happen, right? You would in CSS, you have important or you have the cascade, the specificity that can override values. So this has been thought of in CSS. Obviously, you will still need something like imported in very important cases. And
so it also means in this case when style.width is set and there's a value, all the rest is basically useless.
yes.
Nice.
So that was the order that we had in the previous example. And then 6, and the last one was the static, whatever was in the style attribute. Okay.
Will there be a possibility to, maybe not with styles, but with classes, to merge classes of all directives?
Yeah, that's what happens. If these are, well, that's a really good question.
Because currently version 7, if you override, if a directive and a component override the class host attribute, one of them loses and will not set any, except if you make it class dot something something.
Yeah, so in the new features slide, I mentioned that all of the styles and all the classes get merged.
Okay.
So if this has a height value, so that's your question, the width won't win. But if this has a height value, the height value gets picked up. So it actually does a very, very sophisticated merging of all the styles across every directive. And it does it in O of n time without any extra data structures and no memory, like the memory pressure is very low. So that's what happens, and this enables us to have a bunch of new features. So if you think about CSS in general, if you have a class, and that class has a bunch of properties, but you set an inline style that updates one property, it's not like the class is thrown away. All the other values in the class are still applied. Same thing happens now with the styling changes. So there's a few new things in here. We can have, just as I mentioned with the merge, you can have dynamic styling with directives and components. So before, because ng-style and ng-class were directives, you couldn't have a directive load another directive. In this case, because it's actually part of the core templating language, you can have a host binding for style. And it will take the values and it can apply them directly to the elements. So you can finally have a directive that gets dynamic styles and updates them.
Nice. Thanks.
Yeah. There's also a really good debugging support. So this is what we talked about a few times, where like all the values get merged. And if you were to debug this value in a test, you could just have a styles debug value. And that will just give you a full summary of every single property that changed and the properties that failed to update. And you probably imagine that this code is actually kind of big, right? Like, is it always going to be in the bundle? Well, we have something called ng-dev mode, that if you're in development mode in Ivy, we include all the debugging tools. But as soon as you're in production mode, it deletes all the code, all the debugging code. So tests will work, debugging will work in dev mode, production mode won't have all this stuff.
Nice.
The other cool thing is that there's going to be a window.ng with all kinds of utilities. These are the development mode utilities. So in this case, we'll have something called debug styles, where we can give it an element and we get the same summarization data back from the elements. Let's talk about the big thing that I've dying to work more on. Animation. So like, the animation code doesn't really overlap with styling because we have our own syntax for it. We have our own template language for it. But one of the issues that we're dealing with is that if an animation trigger has styling and then CSS happens to update the same value, you could have a collision. So right when I started working on this, we're like, okay, well, how could this lend itself well to animations? So if you have this component, chances are that you want to update or animate some of these properties, right? Update the width and the height. You don't want to make an animation that's going to go and update its own height and its own width. It'd be kind of cool if you could just have the template code directly. If you could do this, that would be really powerful. And this is what I've built. I'm waiting for Angular 9 to come out until I can release this. Basically, you can take any class, any style. You can take a style map of values. So you can have like ng-styles data, ng-classes data, and you can animate them just by having a pipe. Yes?
Will this, because one of the great things I like about the animations right now is that, for example, when I have, like, I want to have the height auto grow to whatever is in the content, I can use the wildcard.
Yeah. Yes, it does.
Can I use it here as well?
Yeah.
Nice.
Because if you think about it, the wildcard doesn't make any sense unless you have animations, because if you're animating to the height value, it's the same as removing the height. It's only when you have to figure out the animation it gets hard. So that AnimatePipe code that I showed you, you can, and this took me a long time to build, but I actually got it to work where having multiple CSS classes with multiple transitions has not been possible, because if you have one class that defines a transition, you have another class that defines a transition, one of them cancels out the other one. But with this animation pipe, it does it. It uses like a bunch of request animation frames, and it applies values in different ways, which enables you to have multiple classes that all animate in different times, and to have multiple styles that animate as well, and to have dynamic values where if you remove a value, it figures out what the value will be in the end. And it uses transitions. It doesn't use web animations. So that works with older IE browsers. You don't need a polyfill to do this. So I have a demo on my computer with this. So this isn't really the most prettiest website, but here the code is from an earlier build of Angular from a few months ago. So I don't have, actually, I might have, well, I don't have the code in the Angular repo right now. I have it in a pull request, which hasn't been updated for a little while. Basically what's happening is I'm adding a class, and I'm adding another class, and I'm adding another class. So if you think about those lamps, where it gets lighter, 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 and then that's what's happening here. But basically what's happening is every time one of those classes change, it's calling AnimatePipe. So when one gets added and one gets removed, those are two different animations, to remove the old one and to add the new one. And this gets very, very difficult with the existing animation system because you have a collision. What's happening is, does the old height get removed or does the new one get added? What happens if one of them has a different color value and the other one has a different color value? How do you figure out the collision? The nice thing about this is that because it's style bindings, it's up to CSS to figure out. CSS handles it. We're all used to CSS with the cascade. So in this case, you can just add whatever classes you want and it will figure out all the animations for you. And of course, it's very, very performant because all it has to do is just add or remove classes and use transitions. Here we have a height value, and that height value is updating to the auto height. So all we said is we removed the height and we just said animate. And if you look in the background, let me see if I can refresh this page. Okay, so the background color is a class that we're adding. So that's changing to a darker color. But if I change the height, you can still see that the old animation is still animating. Because a class animation is different from a style animation. And that's two different transitions, but it's able to cancel the old one and add the new one, and still have them work cooperatively. So right now, the whole team, including myself, we're all working really hard on Ivy to get this out of the way. And there's a lot of new features I'm adding for animations. And to answer the question about the old system, what's going to happen is the old system will still work with the new system, because what's going to happen, an element gets an animation function, and then it's able to handle both players at the same time. So like there isn't a mind for this. We're not getting rid of the old animation system.
Is it discouraged somehow then? Or is it still valid? The
still valid, yeah, completely valid. This is more of a simple case because most of the time you don't want to set up a whole sequence of steps. You just want to say change this value, I don't care how it animates. And the nice thing is that if anyone's familiar with Animate CSS, the library, you can just dump one of the CSS classes into...
So it gets as easy as it was with AngularJS.
Yes, which I also worked on 5 years ago. But yeah, like the biggest thing that I was missing was the fact that you can just animate classes. Yes?
Can we configure easing?
Yeah. So I didn't put too many examples in here, but this could be a string.
Yeah.
And the string could have 1 second ease out, a delay as well.
Only that parameter, or like a full parameter from the CSS, like delay before animation?
It's the whatever the transition supports.
Okay, which is like a
second delay.
Mm-hmm.
Now there's all these other ideas I have in mind for having like multiple sequences and how this whole relates to them. But this is the first step because this relates to styling. If the styling is really efficient and performant, then we can easily add the animations on top. Now the other thing is that because the animation's a pipe, that means that the inner content of the pipe, the one that actually figures out the animation, could be lazy loaded. So you don't have to boot the website up with all this heavy animation code. You can download it maybe 5 seconds after the page is loaded, and then render it.
And if you want to loop,
I don't see any reason to not say infinite in there. Because with transitions, I don't think transitions support infinite keyframe animations do. But the thing with this is that if you're using style values, you can still convert it to a keyframe. Or you could just have something that's constantly producing the animation. The thing with infinite, though, is that it has to have a loop, and transition is one step to the other step. So it comes down to how much you can experiment with this.
So does it use the animation player?
Web animations?
Animation player from Angular?
No, it's a different interface.
So can you use the dynamic data, like I don't know, the height of length of an array to know the duration or something like that?
Yes, if you have a pipe, the pipe could then take in the styles, figure out what it has to and animate.
Static data.
Yeah. And web animations was one of the options that we had inside of Angular to animate.
Yeah.
It's really good, but the problem is it's very, very strict. You have to know all the styles.
Yeah.
And if you use transitions, it's very, very liberal or free, like to open to animating multiple properties. But the problem is it's incredibly hard to control. It's not a good API. So the thing with this is, just like I had the joystick in the beginning, you shouldn't have to care about what happens behind the scenes. You shouldn't have to care if, like, oh, I need a polyfill, or oh, this doesn't work with web animations. It should just do the whole thing for you and animate it. And of course, with the console tools, window.ng, you can get all the players, you can inspect any element and slow down the animations, repeat the animations to debug it in a much more effective way. Okay, I need to stop this because I'll keep talking. So you saw the demo. When is this coming here? Well, right now the priority is to get Angular 9 out, and the refactor without the animations is about 90% done. I was supposed to finish it a few days ago. We ran into some issues, so it's going to be a couple more weeks. And the animation pipe, I'm just trying to get it into a spot where it doesn't have to be a part of Angular. You can just add it into Angular. So it's not attached into the code base of Angular. That's what I'm working on. But that's it for the talk. I hope you enjoyed this.